Modern air defense systems can neutralize incoming missiles before they reach their target.
Threats confirmed. Engaging interceptors. Interceptors locked. Tracking.
First wave neutralized. Next set incoming.
Final bogey closing. Firing solution ready. Impact confirmed. All threats eliminated.
This animation illustrates the interception of a ballistic missile launched from Iranian territory toward Israel. We will examine the complete sequence using real-world principles of radar detection, ballistic trajectories, and kinetic interception. Welcome to Stylized 250, your source for advanced 3D engineering animations. We create high-quality 3D animations that explain complex technology and engineering systems with clarity and precision. The interception relies on three core scientific principles: early detection via phased array radar, precise trajectory prediction using ballistic modeling, and terminal guidance through active seeker technology combined with high powers. Early detection begins with phased array radar, which uses electronic beam steering to scan the sky. As the system detects an incoming missile's thermal signature, it tracks the target, enabling an interception response. Ballistic modeling begins with velocity and altitude vectors from sensor data. Calculi computer models solid-based inputs, continuously refining the path and pinpointing the intercept location. The missile's active radar seeker head achieves a targeting lock on the threat. High-speed divert thrusters then execute interception. The process begins at a mobile launch platform in Iran. A medium or intermediate range ballistic missile is positioned vertically, with its liquid or solid propellant loaded and guidance systems initialized. At launch, the rocket motors ignite, generating high-thrust exhaust that propels the missile vertically. The initial boost phase produces intense thermal signature and visible plume as the vehicle accelerates through the lower atmosphere. During the boost and early ascent phase, the missile reaches supersonic speeds while following a steep upward trajectory. Its exhaust plume remains clearly visible as it climbs toward the edge of the atmosphere. In the mid-course phase, the missile follows a predictable ballistic arc. After booster separation, the ring at hypersonic velocities at altitudes exceeding 100 kilometers. From a tracking perspective, the missile's trajectory can be modeled as a parabolic arc across the region. Israeli early warning systems continuously monitor this path, calculating time to impact based on velocity and altitude data. Israeli long-range radar arrays detect the missile during its boost or early mid-course phase. The incoming TV-4. Upon confirmation, the integrated air defense network activates. Command and control systems correlate radar data, assign interceptors, and prepare launch batteries while maintaining continuous track of the inbound threat. Surface-to-air interceptor batteries are brought to ready status. Launch canisters elevate, fire control radars lock onto the projected intercept point, and the system awaits final authorization for engagement. The Interceptor missile is launched using a high-acceleration booster. It rapidly ascends on a collision course trajectory, guided initially by ground-based radar uplink. Both the attacking ballistic missile and the defending interceptor are now in flight. The inbound missile follows its fixed ballistic path while the interceptor maneuvers to achieve an optimal intercept geometry. In the terminal phase, the interceptor activates its onboard active radar seeker. It performs real-time course corrections using divert thrusters to close the distance and align with the target's predicted position. As the two objects converge at high relative velocity in the upper atmosphere, the intercept window opens. The system calculates the precise point of closest approach for successful engagement. The destroyed fragments re-enter the atmosphere at steep angles and undergo rapid aerodynamic heating, causing them to burn up before reaching ground level. No intact warhead impacts occur. With the threat neutralized, the air defense network returns to standby mode. Radar tracking continues briefly to confirm debris dissipation, after which systems begin safe shutdown procedures.